All right, let's complete our table of contents. We spent a little bit of time on 1.1. We're now moving on to 2.1. We're now on 2.2. Still dealing with inequalities. This is solving inequalities. And the way the book has it, 2.2 is just with addition and subtraction. All right, so we're going to kind of take our time, even though we're familiar with two-step equations and multi-step equations. The notes I want you to do, unfortunately, we don't have guided notes prepared, so you're just going to have to take out a scratch piece of paper. This could be paper from the back basket near the back of the class, whatever you have resources and access to. But let's go ahead and update this. So we're just going to do this kind of from scratch, just bare bones here. All right, so I'm actually just going to draw this line. If you want to use a straight edge, there are rulers in the back. Let's do this. I'll just say, we'll abbreviate here. We'll just say add and subtract inequalities. You get the idea. We'll probably be abbreviating quite a bit because I don't want you to write too much. On the top right, we'll put 2.2. Top left, today's date will be, we're supposed to put Friday, 9/23. Okay. And that's also going to put this line down the, the center, skewed to the left. Okay. So for this, a couple things that we need to note, and we are familiar with this from properties of equality in chapter 1, but we have properties of inequality. So the first one we're going to write off to the side, we're going to say is the addition property of inequality. Write it out, and then we'll just describe it. So there's a theorem. It says if we'll just we'll use greater than. If A is greater than B, right? They'll represent numbers. We'll say then if I add something and I add it to both sides, that inequality will still stay the same. It'll still prove or produce an equivalent inequality. So then A plus, I'm going to change my color here. A plus C is still greater than, on the right side is B plus, I'll put this in red, B plus C. So if we add the same thing to both sides, it'll still stay equivalent, meaning that the left side in this example is greater than the right side. So an example here, we'll say EX. Let's say 2 is less than 6. All right, well, this is true. Just throw out a random number. Let's say 3. Okay, well, I'll add 3 to both sides, and it'll still produce a true inequality. So left side is 5, right? 2 plus 3. Right side is 9, right? 5 is less than 9. That's still true. All right, so let's actually use this with an inequality. So let's go example 1. All right, we'll solve and graph the solution. So the first one we're going to have just simply x minus 6 greater than or equal to negative 10. Typically, we'll draw a straight line, and that might be too long. Okay. All right, so on both sides, if we want to isolate for x, we need to get rid of this subtraction, this constant of negative 6. We're subtracting 6 by adding 6 to both sides. All right, annotating this, we know that t equals 0, so we circle. And then from here, we'll put x is greater than or equal to, and then on the right side is negative 4. All right, so this, we've isolated x, we've simplified. This is our final solution. But let's go ahead and graph this as well. So this, I'll graph it off to the left, or sorry, to the right. All right, -4. You can create a number line anyway, but I'll start at 0. 1, 2, 3, 4, 5, 6, 7. So this is -5. So -4 is right here. Okay, so first thing we got to think about when you graph this is this an open or closed circle? Since it has equal to, that means it is closed. So above this, we'll put a closed circle above -4. All right, and we have x is greater than or equal to -4. So think of all the numbers that are greater than -4. Is that the numbers to the right? Is that the numbers to the left? So 0 is greater than -4, right? Having $0 is more than owing $4, right? In terms of value. So it's all the numbers off to the right. So this is the solution set for this. And also if we use that special rule, the inequality is pointing to the number. Number indicates that our solution is going to be to the right, right? If we were pointing to the letter, it would be the solution would be pointed to the left. So all this is within the solution set. You could pick any one of these numbers. They will satisfy this first example. Okay, next one. We're going to go to, we just did addition property of equality. We're going to keep it simple here. Let's do the subtraction. I'll put subtract. We'll abbreviate here. Subtract prop of, and I'll abbreviate INEQ for inequality. So the theorem here states that if, we'll create any relationship here, it doesn't matter. If, let's say A is less than or equal to B, okay, then I can subtract something from both sides and it'll still make this, it'll still produce an equivalent inequality. So we're going to say A, I'll subtract, let's say I subtract a value of C from both sides. The inequality still stays the same. Right, less than or equal to B, and then minus C. Right, it's still going to be less than or equal to. All right, good. So let's go to move on to a slight example here. We'll put EX, something that is equivalent. Let's say, or not equivalent, but true. 7 is greater than -5. Okay, let's subtract something from both sides, a random number, -3. Okay. Well, if we subtract something from both sides, this will be 4. And the right side, we'll still have the same inequality. The right side will be -8. So 4 is greater than -8. Yep, that's true. Having $4 is more than owing $8. All right, and let's go to, we'll probably end this with like maybe 2 more examples. Let's go example 2. All right, so solve and graph the following inequality. Let's stick with something kind of just basic here. Let's go with y plus 8 less than or equal to 5. Okay, so in order to solve this, I will have to subtract something from both sides. It's going to be the 8. Actually, I should probably draw this line. Okay. Let's rewrite this. On the left side, we're going to have y is less than or equal to. And on the right side, similar to the problem that we just had, but 5 minus 8 is a -3. All right, we isolated y. Let's go ahead and draw our number line. All right, I'll put 0, 1, 2, 3, 1, 2, 3. -3 is right here. Okay, so y is less than or equal to -3. This will be a closed circle because of the equal to part. And less than is less than, y is less than -3. So what number is less than -3? Right, -4, -5, -6, those are all to the left. Right, give yourself some examples. So it'll be pointed that way. But also here in the inequality, right, it's pointed to the left, or sorry, pointed to the letter. Letter means left. Okay, and let's do one more example. If you have enough room on the front side, keep it on the front side, but I'm going to switch this to the back side because I'm running out of room. Okay, I'll just call this example 3. We'll have one with some rational numbers, so some decimals here. So solve and graph the inequality. Okay, we're going to have negative 8 less than 1.4 plus m. So I'll keep, or let's go ahead and draw this line. Okay. We're still going to use the subtraction property of inequality. So I have to isolate m on the right side. I'm going to subtract 1.4 to both sides. Alright. Now, off to the left, though, when you subtract... Let me zoom in. When you subtract numbers, or numbers that have decimals, which all numbers do, you have to line up the decimal. So in this case, maybe I'll do some scratch work off to the side. Right, this is technically negative 8.0 minus 1.4. Now, same sign, you add and keep the sign. So actually, even though we see minus signs, we see two minus signs. We're combining those. So we're going to add them. This is 4. This is 9. So it's a negative 9.4. 4/10 is less than m. Alright, and let's end this by graphing. Okay, so to create the number line here, I'm not gonna start at 0. Let's start at, maybe go from, I'm gonna put negative 9.0. And let's go by increments of tens place. So this will be negative 9.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and this is negative 10.0. This is negative 9.5. So negative 9.4 4/10 is going to be right here. Open circle, since it doesn't have equal to. Alright, but negative 9.4 is less than m. So think of all the numbers, since this negative 9.4 has got to be the lowest number of all the solutions, of all the numbers in the solution set. So if it's the smallest one, that means I'm going to shade everything to the right here. Right, so if I were to pick one of these numbers, let's say, you don't have to draw this, but I'm gonna pick 9 here. I'll put an X right here. If I plug this in here, right, is this a true statement? I'm gonna plug in negative 9.0. Right, is owing, let's say $9.40, is owing $9.40 less than owing $9? Yeah, you have less money. You're owing more money, right? You're more in debt, more in negative. So it's a true statement. So all these numbers that are to the right of this, right, negative 9.1, 2, negative 9.3, these are all values of our solution set. But also notice our inequality symbol, it points to the number. Number means shade to the right, right? If it points to the letter, that means shade to the left. Anyways, we're going to have a little bit more practice that comes in the form of our 2.2 assignment on big ideas. If you do finish the 2.2 assignment, then you'll just work on any makeup work, or if you don't have any makeup work, then you're working on Prodigy. All right, you're always welcome to email me if you have any questions.